Okay, next we're going to speak about the ASA modular policy framework functionality. We're going to see what that is at a basic level for CCNA exam, and then of course you're going to go to the configuration side, both in the CLI and the GUI, which is going to be the SDM. So again, as I said in the very first few days of the class, like whatever you learn, take a moment and consider the naming convention, the acronym of any functionality, because also MPF, which stands for Modular Policy Framework, it means that to begin with, it's a framework. So being a framework, it means that it has multiple functionalities to begin with. It's not dedicated to a single functionality. Second, being a modular policy framework, it means that this framework, this set of features, allows the ASA policy, the ASA, let's say, inspection engine to be modular. So we're going to see that this is the scope of MPF, to bring to the ASA inspection engine modularity, which means scalability, which means extensions. So like whenever Cisco would want to add a new feature to the ASA firewall, they may want to make use of the MPF functionality. So one main scope of MPF is that it's being used to control which IP protocols are supported for stateful inspection. And when I say IP protocols, I'm meaning about IP protocol numbers, like TCP, it's a protocol number, UDP, it's an IP protocol number, ICMP, ESP, GRV. I'm not speaking about application protocols, because an application protocol like SMTP or DNS or FTP runs on top of TCP or on top of UDP. Any application runs on top of TCP, any application protocol, Layer 7 protocol runs on top of TCP or UDP. So those protocols are actually running on top of TCP and UDP. So what I mean in here when I'm saying IP protocols, I'm saying about which like protocols, not application protocols, like TCP or UDP or ESP or ICMP or GRV or whatever protocol else, like OSP if it's an IP protocol, GRP it's an IP protocol, has its own protocol number to begin with. So with MPF, TCP and UDP inspection is enabled by default and cannot be disabled. So like with or without MPF enabled, TCP and UDP inspection is on by default. So you could say that it's technically like not an NPM functionality, but I just added there, to clear up any confusion. Although, as I said, the fact that you can disable MPF completely on the SA and still statefully inspect TCP and UDP, this means that TCP and UDP inspection are not per se an MPF functionality. If you want to look at it like that at this feature. Like for example, out of IP protocols which are support for stateful inspection are going to be ICMP and ESP, and none of them are inspected by default. Like the ASA doesn't support the inspection of out of IP protocols like GRE, for example. So it means that if you send GRE traffic to the ASA, you cannot statefully inspect the GRE traffic, which means you have to make sure that traffic is allowed both ways, either by the security levels or by the ACL configuration. Like for example, if you look at the diagram in here, and currently we have security level of 100 in here, 100 on this interface, the inside, and of 0 on this interface, the internet one. So what this means is that if, for example, you would want a GRV tunnel to work between router 1 and router 4 through the ASA firewall, a GRV tunnel, per our configuration, GRV traffic would work one way from router 1 to router 4, because traffic flows high security level interface to low security level interface, so 100 to 0, and since we don't have any ACLs configured in that direction, it is going to be allowed. But so traffic is going to flow that way, but then GRV, it's a bidirectional traffic flow. GRV traffic from router 4 to router 1, it is going to be blocked, and you cannot inspect that with MPF. It's not supported. So for the GRE traffic to also work from router 4 to router 1, which is going to be a requirement, you would want GRE traffic to work both ways. It means you got to go inbound on this interface And in that inbound ACL which is applied in there, you have to allow GRE traffic between those two IPs, router 4 and router 1, between the source and the destination. So to begin with, ICMP and ASP it's supported for inspection to be statefully inspected by the ASA, but it's not turned on by default. Because, as I said, it brings scalability and modularity to the ASA inspection engine. MPF is also used for other purposes. It's used for advanced TCP inspections, which means, for example, you could go and do some you could go and, for example, tell DSA to allow packets flowing through only with a specific maximum segment size value, for example. So you could configure DSA to further look in the TCP header, in the flags, in the options in there, and configure some restrictions back and forth. Or, for example, like TCP options, if you're going to allow TCP options in a TCP session through DSA or not, which by default is not allowed. So those kinds of inspections are supported. Also, it's supported for deep packet inspection and quality of service. So if you want to configure quality of service on DSA, you're going to make use of the MPF engine. And deep packet inspection would mean, like, for example, if looking at a diagram, if you would have let's say HTTP traffic, you would have HTTP traffic in this direction from router 1 to router 4, let's say. Of course, to begin with, this traffic has to, the flow has to be allowed by ASA's security level functionality or ACL functionality. So MPF is not used to allow traffic back and forth to the ASA. It's used to perform advanced inspections or to also statefully inspect other protocols passing through the ASA. So if you would have that HTTP session between router 1 and router 4, and let's say the destination router 1 would actually state, would say www.cisco.com, let's say cisco.com. So this is what router 1 actually puts in the browser. He wants to access cisco.com, and actually it ends up initiating an IP session destined to router 4. You can go on the ASA and you may state to drop traffic, to drop HTTP traffic. If it's destined to, for example, let's say if it's destined to www.xyz.com. It means that the session to cisco.com is going to work. But then when router 1, so that this session is going to be okay, it's going to be allowed by the ASA. But then when router 1 also says, I want to go to xyz.com, and then initiates a session also, let's say destined to actually also, let's say router 4 or out in that direction. So xyz.com is reachable out in that direction. Now the MPF engine on the ASA, the MPF engine, it is going to drop that traffic. So deep packet inspection means you're gonna configure the ASA to look at the application header, at the layer 7 header of HTTP or FTP or DNS or other supported protocols, and perform some inspections. And if the traffic it's not, let's say it's not conform per the ASA policy, it means the ASA is going to reset or drop the session at that point. So this is deep packet inspection functionality on the ASA, which you can do with MPF. Likewise, it's also used MPF to redirect traffic passing through the ASA to a software or hardware module of the ASA. Depending on the physical model of the ASA, it may support a software module or a hardware module, and those can be the old IPSF Cisco intrusion prevention system, or the CX, which was like the proxy functionality on the ASA, the Iron port brought on the ASA, and Firepower module, which is going to be like the source fire functionality or Cisco's next generation firewall functionality. So if you want the ASA to perform some advanced inspections of type IPS or CX or to the Firepower engine, you will also redirect that traffic flowing to the ASA via the MPF engine to those modules. Like looking back at the diagram again, It means that, for example, let's say that you split this ASA. So you have a model of the ASA which supports, doesn't matter if it supports a software or hardware module. So we divide the ASA into two, and then like at the top we're going to have the ASA firewall functionality, the ASA module, and at the bottom we're going to have the, let's say, IPS module or firepower module. Let's say firepower module, the next generation firewall functionality of the ASA firepower module. So now if you configure via the MPF DSA so that all traffic is being redirected to the firepower module, what this means is that if we have a traffic flowing, let's say, in this direction to the ASA, so initially, likewise, traffic first is going to be inspected by the ASA module. It has to be allowed by the ASA configuration, like security levels, access lists, NAT, whatever you put in there. Then the ASA is going to redirect that traffic to the firepower module for advanced inspections. And if firepower module says drop that traffic for whatever reason, then traffic is being dropped. If the firepower module says, okay, traffic is not malicious, is valid, is okay, it's going to tell the ASA module again, I'm done with the inspection, traffic is valid, it's okay, it's not malicious. So then the ASA is going to say, okay, so now I can route the traffic out to its destination. So this traffic is being redirected over the backplane of the ASA to any of those three supported software or hardware modules. Okay. Now let's speak about the building blocks. So what are the, let's say, not configuration wise, but always in general, as I stated throughout a class, you have to understand, once you understand the scope of functionality, before you go to the configuration side or whatever, you have to then understand what are the blocks of that feature and what is the scope of each block within that feature, and how are the blocks connected, and then you go to the configuration side, because at that point you know like which pattern to follow, and you know where technology, if something doesn't work, you know where it can break, because you visualize those building blocks of each function, of each feature. So MPF configuration is very similar with the MQC syntax, which MQC stands for Modular Quality of Service, MQC on the iOS. And MQC is being seen on the iOS in the zone-based policy firewall. So it's kind of a very similar configuration, and it's likely like the same building blocks back and forth, although the syntax in the end is a bit different because it's a different code, the ASA and the iOS code. So the building blocks of the MPF are going to be like in MQC is going to be, you have to match on the traffic by using class maps. So then you can use a layer 4 class map or a layer 7 class map, meaning that if you want to do DPI, you're going to use a layer 7 class map. For all other functions of MPF, you're going to use a layer 4 class map, which means you can match on the traffic in a layer 4 class map using an access list, or using a TCP or UDP port number, or using any kind of layer 3 or layer 4 let's say information from the headers, like for example the QoS marking, for example. Once you match on the traffic, you're going to go and define the firewall policy using policy maps. In the policy map, you're going to define what action do you want the firewall to take on that traffic which you match in the class map. And likewise, you have a layer 4 policy map or layer 7 policy map. So if you want to do DPI, it means you're going to configure a layer 7 policy map. If you want to do just regular inspections on the ASA, you're going to use a layer 4 policy map. So the class map type has to match the policy map type. Layer 4 class map is going to be called within a layer 4 policy map. Layer 7 class map is going to be called or binded into a layer 7 policy map. And then finally, so once you measure the traffic in the class map, you define the firewall action for that traffic in the policy map. Then you enforce the policy using the service policy functionality. And now the service policy can be applied in two ways, either globally which affects all traffic passing through the ASA. So all traffic matching your configuration passing through the ASA is gonna be inspected as your MPF configuration. Or you can apply the policy map at the interface level, which means it's going to affect only traffic passing through that interface. Like for example, if we look at our diagram back again, and let's assume we would have another interface in here as well of the ASA, and this would be our DMZ interface, which stands for demilitarized zone, which means it's not trusted, is not also not trusted. So in our case, this interface is facing the internet, so is the untrusted interface of the ASA. This interface faces the inside, which means is a trusted interface. Although of course nowadays nothing gets trusted in a network, we have to control everything back and forward. But from back in the days, the interface facing the inside network was called a trusted interface of the ASA, and the interface facing the internet or the WAN was called the untrusted interface. So this is going to be the untrusted, and this is going to be the trusted one. Now the DMZ interface usually points to services. You're gonna have in here some kind of services, like let's say HTTP services, FTP services, what else, let's say SMTP services. So some servers in there offering those services, and those services are accessible in general by both the inside network and the outside network. So the DMZ interface, the DMZ part of the ASA, it's not trusted, it's not untrusted, it's a demilitarized zone. So it's a zone of the ASA firewall which has some resources which are reachable from both the protected network, the inside, and the unprotected network, the outside. So we put it in that zone called a DMZ in order to better control who can access those services and how. So we're going to control which users from the inside can access which services from that area, from that DMZ, and which users or which companies or which users from the internet can access which services from that zone of the firewall. So given this, let's say, design with DMZ inside and outside, what this means is that if we, for example, configure an MPF policy for HTTP inspection, for DPI, and we apply the MPF policy on the outside interface, on that internet-facing interface, it means that all traffic flowing through that interface, like in this direction, outside or internet to DMZ, in this direction, outside internet to inside, is going to be inspected by that MPF policy. But traffic flowing between DMZ and the inside is not going to be inspected by that MPF policy, because traffic flows DMZ inside. Traffic doesn't flow through the interface where the MPF policy is being inspected. Now we have some default settings with the MPF. So ASA has a default class map configured, which is named inspection default, and it matches on all traffic. We're going to see exactly what that means in a couple. So it matches on a lot of, let's say, protocols by default. And also ASA has a default policy map configured, is named global policy, and this policy map has the default class map attached or binded, and it also performs some default layer 3 and DPI inspections as well. We'll see in a couple what inspections are being performed by the ASA by default, because that policy map, the default policy map named global policy, is being applied globally on the ASA, so it affects all traffic traversing the ASA. So by default, the ASA has some built-in MPF settings which are also enforced to control traffic flowing through the ASA back and forth through all interfaces, because the policy map is applied globally on the ASA. Now we're gonna configure ICMP inspection, because by default it's not not inspected. So what this means is, we're gonna see when we go to configuration side, is that, for example, if we send ICMP traffic, if we ping, for example, from router 1 to router 4, this is gonna be the echo request. Traffic is gonna be allowed because we go high 100 to low 0, and there is no access list in that direction dropping the traffic. But then when router 4 replies with the echo request, because now traffic flows high to low, 0 to 100, and because my access list doesn't, and because ICMP is not statefully inspected, and also because my inbound ACL configured on that internet interface doesn't allow ICMP echo replies, then this traffic is going to be blocked. So we're going to perform ICMP inspection so that I can ping through the ASA. So the ASA is going to statefully inspect ICMP traffic. And of course, the only, let's say, because ICMP it's a layer 2 protocol which is aimed for troubleshooting purposes, the only, let's say, 2 ICMP types or codes, actually, types, the only 2 ICMP types which are, let's say, pseudo stateful is pinging, because you send an echo request and you expect an echo reply. Pretty much all other ICMP packets are not really stateful, are only, troubleshooting purposes, like when a fragmentation has to happen and the router cannot fragment the packet because the DF bit, the don't fragment bit, is being set, is going to return back an ICMP packet to big message. So in general, ICMP packets are unidirectional. Like you send one IP packet outside, and because of a lot of reasons, when a device drops a packet, it's going to send back an ICMP packet. So that's not stateful. The only stateful ICMP packet is the pinging, because you send an echo request and you expect an echo reply.